In distribution models, master-slave replication is one of them. It is one of the replication distribution models. In the master-slave replication, it is again, we are back to the clustered servers. So there are several servers, and one server acts as a master server. Only this master server will be able to manage all the write operations, while all the slave servers will take the data that the master just wrote, and it will scatter across all the servers, all the slave servers. So basically the master will only write and the slaves will only read. That's all they're significant for. Now we have to understand why this is most commonly used. Well, master slave replication is particularly useful when our application requires more read operations than write operations. Read operations because, well, the work is distributed across many slaves. It can be any amount of servers. The work is basically distributed. So performing a read operation will be really optimized and it will be quick. It will basically perform read operations much better than write operations. Why does it not perform write operations better? Well, write operations are still only done by only a single server. So if there is a really huge load of write operations all of a sudden, it basically may not work properly. It may bottleneck it. So whenever we have more read operations than write operations, or whenever we have more read operations, master slave replication is extremely good. Another advantage is it has read resilience. Let's say the master server died for some reason. Let's say the server is not working. The master server is completely inactive now. Even though the master server is dead, you can read the data on the slave servers completely. All the slave servers can still perform the read operations. But we should not forget that the write operations will completely be paused until there is a new master or the current master has been revived some way. So in case of a master failure, let's say if the master died, it can be recovered in two ways. It can be done automatically or manually. Most databases or servers provide a way to automatically revive the master in order to basically reduce the downtime and the manual work needed to activate the master server again. And in this meanwhile, the slave servers can still work on the read operations. So in order to achieve read resilience, it is important to use two different paths for read and write. So you should basically wire the read path and the write path in two different paths. But we have to ensure that even though we have separated these paths, the write operations and read operations are going flawlessly without any problem. That's what we have to ensure. Well, the master-slave replication does have a challenge, that is data inconsistency. Different clients reading from different slaves might see different values because updates may not have propagated to all the slaves. This is the main problem because they lack consistency. So whenever a master writes, it may not basically propagate to all the slaves. And the client may not even see the write operation that the master just performed. So this is a major concern whenever we are using a master replication model. So this is how it basically looks like. So this is a server. This is another. All of these are servers. This one is acting as the master server. These all three are slaves. So whatever this writes, this will be stored in all these servers. That's it. Again, here, whenever the master is dead, either it's restored or a new master is appointed. We have to keep that in mind. That's what master-slave replication is.